In this screencast, I'm going to describe how to use an interactive simulation that models the ideal gas law. And what we want to show is the different types of behavior that's possible. For example, as we raise the temperature, what are the possible changes in pressure and volume? And so let's look at the simulation. It's located here on the LearnChemE website, and observe the behaviors. So here's the simulation, and from this drop-down menu, select the constant pressure, and then observe that as we add heat, the temperature goes up and the volume goes up, as you expect from the ideal gas law. The bar graph on the right does not have a scale. It's just showing relative values. The actual numerical values are shown here in the graphic. Notice total volume and total heat added. And if I look at constant volume instead, and now I add heat, well, now the pressure and the temperature goes up, the volume doesn't change. And now at constant temperature, what I'm going to do is increase the pressure, which decreases the volume, increases the pressure, and the temperature doesn't change since it's constant temperature. For adiabatic and reversible, now I'm going to increase the pressure. Now notice all three things are changing. Pressure is increasing, volume is decreasing, temperature is increasing because we're doing work on the gas. Well, the last case, a bit unusual. We have a case where we have an external spring, and at the start, the spring is just touching the piston, so it's not exerting any force. As we add heat, notice what happens. All three of the properties, pressure, temperature, and volume, all increase. We're still satisfying the ideal gas law, so they're increasing. Well, this simulation has details for each of these options, showing the equations that govern the behavior. And the whole objective here is to show that there's multiple ways that the variables can change as we add heat to a gas that's an ideal gas.